Today we're going to talk about a brand new topic, and that topic is called radicals. Now, what is a radical? A radical is just another term that encompasses all the different types of roots. So we have square roots, which is the typical one, but we also have cube roots, we have fourth roots and fifth roots and sixth roots. There's lots of different roots, but what those are all called are the radical. The radical is pretty much the symbol of the square root symbol, and we'll look at that a lot today. So when we think of radicals, as I said, square root, what number times itself gives you your answer? The key there is itself, and that's why I have it bolded and underlined. What number times itself gives you that number? So let's look at some examples. Square root of 25. Now, when we say the word radical, the radical is just this sign. So this symbol right here is considered a radical. So if ever you hear me say, what is the radical, or the number underneath the radical, or move the radical, the word radical means this symbol right there. What we have is our square root symbol, okay? So the square root of 25 says, what number times itself gives us 25? Well, most of us know that 5 times 5 is 25, right? What number times itself gives us 25, and that number is 5. So the square root of 25 is 5. What is the square root of 16? What number times itself gives us 16? Well, 4 times 4 is 16, so the square root of 16 is 4. What number times itself? Sometimes people want to do half, so the square root of 16, they would say 8, but remember, it's not half, it's what number times itself gives you that answer. Okay, well, what happens if I give you the square root of 12? What's the square root of 12? So what number times itself gives us 12? And the answer is nothing. There is no square root of 12. There is no number in the entire world, positive, negative, decimal, fraction, doesn't matter, multiplied by itself gives us 12. Something times something else could give us 12, but the same number times itself is not going to give us 12. We can do 4 times 3, we can do 6 times 2, but no number times itself gives us 12. So the square root of 12 is nothing. There is no square root of 12. What we're going to do today in today's lesson is we're going to simplify this radical. So while we can't actually solve the square root of 12, we don't know what it is. Even if you push it on your calculator, you get the square root of 12. It comes out with a really long decimal. That decimal is not actually accurate. It's not exactly right. It's just an estimation. It's rounding it. So it's not exactly correct, that decimal on your calculator. There is no square root of 12. But what we're going to do today is we're going to simplify this radical, just like you can simplify a fraction. We're going to simplify the radical and break it down as much as possible. What if I ask you the square root of negative 49? What times itself gives us negative 49? And the answer is nothing. Because if you think of 7, well, 7 times 7 is 49, correct, but not negative 49. And if you think of negative 7, well, what's negative 7 times negative 7? Positive 49. It's positive 49. So there is no square root of negative 49. In fact, there's no square root of any negative numbers. And we talked about that at the beginning of the year. The square root of a negative number becomes what we call an imaginary number. It's called an imaginary number. And if we have time, we will get to that also in a different video. The square root of negative 49. There is no square root of negative numbers. But what we're going to do today is we're going to take radicals like this one, and we're going to simplify it. We're going to reduce it down. Now, before we get started with that, the main thing we have to know, and some of you may already know this, some of you may not, is you need to know your perfect squares. So the perfect squares are the numbers that work, the numbers that do have a square root. For example, what's the square root of 25? 5. What's the square root of 16? 4. What's the square root of 36? 6. What's the square root of 9? 3. Those are what we call perfect squares because they have square roots. However, what's the square root of 12? There isn't one. What's the square root of 15? There isn't one. What's the square root of 8? There isn't one. Those are called non-perfect squares. What we're concerned with are the perfect squares. So we want to know the numbers that are perfect squares, the ones that work. So what we should have, and you should have this in your notebook somewhere, I highly suggest you print this out, you have it pulled up on your phone, you write this down in your notebook. You need to have this list of perfect squares. I promise you in this lesson and in the next one, this is going to help you out tremendously. If you don't already know your perfect squares by heart, write this down somewhere or print it out somewhere because you're going to need this list. It will make things much, much easier, and you'll see why in a second. So here are our perfect squares. We start with 1. 1's our smallest perfect square. 1 times 1 is 1. 4, 9, 16, 25. These are perfect squares. These are our first 15 perfect squares. Obviously, there's more if you keep going, but I think 15 is probably good enough for this class. First 15 perfect squares are right there. So having this list in front of you is going to make simplifying these radicals much, much easier. So let's go into that now. All right, so this is simplifying radicals. To simplify a radical, it's basically doing it just like when you simplify a fraction. We're breaking it down. We can't actually answer it. We can't actually solve it, but we can do is simplify it down so that we're able to work with it. Earlier, I said, what's the square root of 12? And we talked about how there isn't a square root of 12. There's no number times itself that equals 12. So what we need to do to simplify it is this. You need to think of two numbers that multiply together to equal this number, and one of those two numbers has to be a perfect square. Okay, I'll say that again. You want to think of two numbers that can multiply together to equal this number, and one of those two numbers has to be a perfect square. One of those has to be in that list that I just gave you. So let's think about all the ways I can multiply to get 12. Well, 6 times 2 is 12, but is 6 or 2 a perfect square? No, neither of them are. So let's keep going. Well, 4 times 3 is 4 a perfect square? Yes, 4 is in our list. So we can break this up into square root of 4 times the square root of 3. Okay? So think of two numbers that multiply together to equal this number. One of those two has to be a perfect square. In this case, 4 is a perfect square. So 4 times 3. And then what we do is we look at each one of these separately. So what is the square root of 4? 2. So the answer to this question is 2. The square root of 4 is 2. We write down 2. You do not put square root of 2. Okay? It's just 2. Square root of 4 is like asking, what is the square root of 4? The answer to that is 2. So you just put 2 down. Now, what is the square root of 3? There isn't one. So we leave that as square root of 3. So that is my answer. 2 square root of 3. We have simplified square root of 12. We broke it up into two numbers that multiply together to equal 12. One of those two has to be a perfect square. The square root of 4 is 2, so we make that a 2. Square root of 3, we don't know what square root of 3 is, so we leave it where it's at. So our answer is 2 square root 3. It's actually 2 times the square root 3, but we just write it like that, and we phrase it by saying 2 square root 3. Okay? So let's do another one. Square root of 18. So once again, is 18 a perfect square? No. If it's a perfect square, if this said what's the square root of 25, you just write down 5. If it says the square root of 49, you just write down 7. But if it's not a perfect square, we need to simplify it. So let's think of two numbers I can multiply to give us 18. One of those two has to be a perfect square. All right, so think of all the ways you can multiply to get 18. 6 and 3. Well, 6 nor 3 is a perfect square. What about 9 and 2? 9 is a perfect square. So we can break this up into the square root of 9 and the square root of 2. Now, what is the square root of 9? 3. So that becomes a 3. What is the square root of 2? We don't know, so we're going to leave it as square root of 2. So we have simplified this radical down to 3 square root 2. Just like we simplified this radical down to 2 square root 3. Okay, let's do one more. Square root of 72. So 72 is not a perfect square. It's not in the list. So let's think about all the ways I can multiply to get 72. There's a lot of them. Well, the first one that comes to my mind is 9 and 8. 9 and 8. So let's do 9 and 8. And 9 is a perfect square. So square root of 9 and square root of 8. Okay? What is the square root of 9? 3. Square root of 8. Now, this is not our final answer. And you should notice that it's not our final answer because if you think of the number 8, you can break up square root of 8. Can you think of two numbers that multiply together to equal 8 and one of those is a perfect square? You should say yes. The answer is 4. So I can break up 8 again. I can reduce it again and make it 4 and 2. Now this 3 has to stay on the outside. So once again, square root of 9 became 3, square root of 8 stays square root 8, but then you should break up the square root of 8 again. So that becomes square root 4 and square root 2. Now what is the square root of 4? 2. So what we're going to do is this becomes a 2. Along with this 3, we have to multiply them. So here's a 3, this is a 2. This has to stay square root 2. And now be very careful with these. We're going to multiply them. Sometimes I see people want to add them. Sometimes people just make it 32. We're going to multiply those two numbers. So our final answer, 3 times 2 is 6, square root 2. And that is my answer. Now the question you may have is, how do I know when I'm done? How do I know that I can't keep breaking it down? Because in this one, I broke it up, made it 3 square root 8, but then I had to break it up again. And the key is looking inside the number that is underneath the radical. Can I break it up? Can I break up square root of 2? Is there two numbers that multiply that equal square root 2, or that equal 2, and one of those is a perfect square? The answer is no. Whereas on 8, I could break up 8 into 4 and 2. So if you can break it up, if there's a number that is a perfect square that goes into it, if it has a perfect square factor, then you need to keep breaking it up. Now on this one, there's a different way I could have done it. So my suggestion is always at the beginning, when you are breaking this up into two numbers, try to find the largest factor that is also a perfect square. Try to find the largest one. So we use 9. 9 goes into 72, 9 times 8, and 9's a perfect square, it works. But if there's a number that's bigger than 9, that also goes into 72, and is a perfect square, we should use it. And in this case, there is 36 and 2. 36 times 2 is 72, and 36 is a perfect square. So now I made 36 and 2, and I can break it down. What is the square root of 36? 6. Square root of 2 stays the same. And if you notice, we get the same answer either way. Either way works. It's just like simplifying a fraction.